Hey, so if you're a Python developer and you're really trying to land a backend or a DevOps role, well, this is exactly what you need to hear. Today, we're diving deep into Docker, and trust me, this is the tool that's going to seriously level up your career.
And listen, that's not just some hype. It's the truth. Mastering Docker gives you a huge advantage. Why? Because pretty much every modern Python application you can think of, from web APIs to data pipelines, you name it, they're all deployed using containers. So let's break down exactly how you can make this skill your own.
We've got a really clear roadmap for this. First, we'll talk about why Docker is so essential right now. Then we'll walk through the core workflow, build our very first app, scale it up a bit, and finally, we'll get you prepped for the exact questions you're going to face in a job interview.
All right, first things first. Why is everybody talking about Docker? Why is this showing up as a non-negotiable skill on so many job descriptions these days?
The magic of Docker really is all about consistency. It finally solves that classic frustrating problem of, well, it works on my machine. By bundling up everything your app needs, the code, the pip packages, even the system libraries, into one single portable thing called a container. And this container will run the exact same way on your laptop, your colleague's laptop, or a production server in the cloud. No more surprises.
Now you might be thinking, hey, wait a minute, isn't this what virtual machines do? And you're on the right track, but Docker is just so much more efficient. See, a virtual machine has to bundle an entire guest operating system, which is super heavy and slow. Docker containers, on the other hand, just share the host's operating system kernel, and that makes them incredibly lightweight and ridiculously fast. We're talking starts in seconds, not minutes.
Okay, understanding this core workflow is absolutely crucial. It's a really simple, three-step process that takes your code from just being a bunch of instructions to a live, running application.
And this analogy here is perfect. Think of it like baking. The Dockerfile, that's your recipe. It's got all the step-by-step instructions. When you build it, you create an image. That's like a frozen, ready-to-bake snapshot of your application. And finally, when you run that image, you get a container, the actual running process. So it's just recipe, snapshot, process. Super simple when you think about it that way.
All right, that's enough theory for now. Let's get our hands dirty and actually see just how easy it is to containerize a really basic Python application.
We're going to start with the simplest possible app you can imagine. A single Python file, let's call it app.py. And all it does is print a simple hello message. This is the piece of code we're going to package up.
Next up, we create our recipe, the Dockerfile. So let's break this down. First, from Python 3.12 Slim tells Docker, hey, start with this lightweight official Python environment. Then, workdir app just creates a folder inside our container for our code. Copy app.py does exactly what it says. It copies our script into that folder. And finally, cmd tells the container what to do when it starts up. In our case, just run our Python script.
So, with those two files in place, we just run two commands in our terminal. First, docker build, that creates the image from our Docker file. Second, docker run, that starts a container from that image. And there you have it. You'll see the output right on your screen. Hello from Dockerized Python.
Okay, but what if we go back and change that message in our app.py file, and then we rebuild it? Does Docker have to do all that work again right from scratch?
The answer is a big no. And this right here is a crucial point for interviews. Docker uses a layered file system, and it is incredibly smart about it. Every single instruction in your Docker file creates a layer. When you rebuild, Docker only rebuilds the layers that have actually changed. This is exactly why in real projects, you always copy your requirements.txt file and run pip install before you copy your application code. Your dependencies rarely change, so that slow installation step gets cached, making every single build where you only change your code super fast.
So a single container is great, but let's be honest, real-world apps are way more complex. They usually need a database or maybe a caching service or background workers, and that's where Docker Compose comes into the picture.
So the key takeaway here is this. Anytime your application isn't just one single isolated process, you should probably reach for Docker Compose. I mean, if you need a web server talking to a Postgres database, or you need a Redis cache or a Celery worker chugging away in the background, Compose is the tool that lets you define and run all of them together, seamlessly.
And you know what? The configuration for this is surprisingly simple. You just have one file, dockercompose.yaml, and in it you define each part of your app as a service. So here we have a web service that we build from our local Docker file and a DB service that just pulls the official Postgres image straight from Docker Hub. Then, with just one command, Docker Compose up, Both containers start up and are automatically networked together. It's that easy. Now, as you start thinking about production, a few best practices become really important. Always use those slim base images to keep the size down and reduce security risks. Swap out the built-in development server for a real production-grade one like Junicorn. Use a .dockerignore file. It works just like .gitignore to keep secrets and junk out of your image. And finally, you'll want to learn about multi-stage builds to create a final image that has only what it needs to run, making it super lean and secure.
So how does all this get you that job? We've gone over the concepts, but now let's laser focus on the interview questions that you are very, very likely to be asked.
This is the classic #1 question, and you already know the answer. The image is the blueprint, right? It's the frozen snapshot. The container is the running instance of that image. It's the recipe versus the actual cake.
Here's another really common one, and you can mention a bunch of things we just talked about, using slim base images, using a Dockerignore file to exclude stuff, and for bonus points, definitely mention advanced techniques like multi-stage builds.
And here's the third question that's almost guaranteed to come up. Docker Compose is a tool for defining and running multi-container applications, and you use it whenever your app is made up of multiple services, like a web server and a database, that need to run and talk to each other.
Okay, so how do you put all this together to really impress a recruiter? Here's your action plan. Build a project that shows you get the modern stack, something like a FastAPI web app with a Postgres database. Then, show you can handle complexity. Add Redis for caching and a Celery worker for background tasks. Tying it all together with a clean Docker Compose file and putting that project on GitHub, that shows you can build and manage a complete real-world application. That's the kind of portfolio that gets you noticed.
And let's just end where we started. This isn't just about learning a new tool. Seriously, mastering Docker and Compose fundamentally changes how you're seen as a developer. It shows you don't just know how to write code, but that you know how to build, package, and deploy real-world, production-grade applications. You now have the foundation to become a backend-ready developer. So the only real question left is, where are you going to apply these skills first? Are you going to go containerize one of your old projects, or maybe start building that awesome portfolio piece we just outlined? The next step is all yours.